Exercise 21.5, question 4. So in this situation here, we have somebody playing volleyball and they serve the ball from a height of 1 metre with a speed of u at an angle of 35 degrees. So the projectile is going to look something like that. And we're asked to, in part 1, define a suitable origin and x and y axis and find the equation of the trajectory of the ball in terms of x, y and u. So it seems sensible that our origin is here, and this would be our x-axis, and this to be our y-axis. And then we know we're going to write down some information that we know. So we know the initial velocity, the initial displacement is 0 and 1 because it starts at a height of 1, and its initial velocity is u cos 35, u sine 35, and the acceleration is 0 and negative g, because the only force acting is gravity, which is acting downwards. And then at a given time t, the displacement, well, let's call that x and y. So the displacement at some time t is x, y. And then if we start putting that into the Suvad equation, r equals r0 plus ut plus a half at squared, we get xy equals 0, 1 plus u cos 35, u sine 35, t plus a half 0 minus g t squared. And we can read off two equations from the horizontal and vertical components. So taking the horizontal component, we get x equals ut cos 35. And reading off the vertical components, we get y equals 1 plus ut sine 35 minus g over 2 t squared. And the question wants an equation in terms of x, y and u, so we need to eliminate t. Well, perhaps the easiest way to do that is to rearrange this one here to make t the subject. So dividing throughout by u cos 35, we get t equals x over u cos 35. And substituting that into here, we get y equals 1 plus u sine 35 times t, which is x over u cos 35, minus g over 2 x over u cos 35 all squared. And that is an equation in terms of x, y and u, but there is a little bit of simplifying we can do because these u's cancel, and we also know that sine 35 divided by cos 35 is tan 35, so y equals 1 plus x tan 35 minus g over 2 x over u cos 35 all squared. Okay, so that's part 1. In part 2, we're given a bit more information, and we're given that the serve is taken from a distance of 3 from a net that is 2 meters high. So we know this is 1 meter, and we know the distance from the net is 3, and we know the height here of the net is 2 meters, and we're also given that the other end of the court is 5 meters long. And in part 1, we're asked to find the minimum value of u for the ball to pass over the net. So what we're looking at here is we're looking at the situation where the ball just goes over the net. So we're not looking at this black line, we're looking at this green trajectory here, and we want to work out what value of u makes that happen. Well, let's think about this point here. What we know at this point here. Well, we know that if it just passes over the net, it passes through this blue point here. So what's true at this point, blue point here? Well, it's true that x equals 3 and y equals 2. So we've got this equation from part 1 in terms of x and y and u. So if we substitute this information into this equation and solve for u, we can work out the minimum value of u for the ball to pass over the net. So let's do that. We put that in, we get 2 equals 1 plus 3 tan 35 minus g over 2, 3 over u cos 35 all squared. And all we need to do now is solve that for u. Well, let's add this last term to both sides and subtract the 2. So we get g over 2, 3 over u cos 35 all squared equals 1 minus 2, so minus 1 plus 3 tan 35. Multiply that through by 2 and divide it by g and then take a square root. We get 3 over u cos 35 equals 2 over g lots of 3 tan 35 minus 1 all square rooted, and we don't need to worry too much about a plus minus here because we know that u is a speed, so it's going to be positive. And now we just need to solve for u. So if we reciprocate both of those, we get u cos 35 over 3 equals 1 over the square root of 2 over g 3 tan 35 minus 1. So u equals 3 over cos 35 lots of the square root of 2 over g 3 tan 35 minus 1. And if you put that into your calculator, you end up getting approximately 7.73 meters per second. Okay, right, part 3. So part 3 is a similar situation, but in part 3, we are asked find the maximum value of u for the ball to land inside the court. So what we want here is we want to find the value of u that has this trajectory where it just lands in at this point here. So if u is any greater, it lands out here, so beyond the 5 meters, so it is out. So let's think about what is true at this red point here. Well, we know x is 8, and we know that the height here is 0. So again, we can take our same equation from part 1. What we want to substitute in here are the values y equals 0, x equals 8. So let's go ahead and do that. We've got y equals 0, x equals 8. So let's just do this here so we can see 0 equals 1 plus 8 tan 35 minus g over 2, 8 over u cos 35. Okay, so let's copy that down here. 0 equals 1 plus 8 tan 35 minus g over 2 lots of 8 over u cos 35 all square rooted. And I'm not going to do the rearranging because I think that is something you can do yourself. If you rearrange that, you end up with u equals 8 over cos 35 times by the square root of 2 over g 1 plus 8 tan 35, and evaluating that in your calculator, you get that that is approximately 8.41 meters per second.